Hello, ladies and gentlemen. Today we're going to be talking about quadratic attributes, both mathematical and real world. You'd like to have your note sheet up, and it should be this note sheet here. And we're going to go through a short PowerPoint to give you the information that we need to know about the parent function of quadratics, as well as what happens when we have a transformed quadratic function and we want to find its attributes, such as the axis of symmetry, the vertex, and our roots, zeros, x-intercepts, or solutions. So these will be big parts of our vocabulary. Another part we'll be talking about concavity. So whether it faces up or down, which lets us know if it has a minimum or a maximum. Let's go and let's begin. We'll start at the top and talk about the parent function and its attributes. So the quadratic parent function is the equation y equals x squared. And it has certain attributes. So some information that we'll see is that it has a vertex at 0, 0, one real root at 0, 0, and so the roots will find out that it's where it crosses the x-axis, or where it touches the x-axis. Also an axis of symmetry, so you have to think back to symmetry when you learned in middle school, and what that means about the graph of this function. And it's concave up. So to give us a view of our quadratic function, the parent function and what it looks like, it's this graph right here. So our vertex right here at 0, 0, it does touch the axis there as well. So that's also our root. The axis symmetry would be a vertical line that would cut it in half. And concavity, which way is the u facing? Is it pointing upward or is it pointing downward? And in this particular case, the parent function is pointing upward, and we call that concave up. As we talk about transformed quadratic functions, they won't be x squared. They'll be in the form of y equals ax squared plus bx plus c, where a, b, and c are just numbers. And so we call this the standard form of a quadratic function. Make sure that you've copied all the material down. We'll wait about 30 more seconds before we move on. Okay, as we move on, we're going to go ahead and analyze the graph of the quadratic function that is graphed below. So this quadratic function has certain attributes, and we'll go and we'll start to take a look at them here. So one of the attributes is if it's concave up, our a value is positive. That'll be an important attribute. Since this one's facing upward, our a value will be positive. And so any quadratic function that's a u facing upward would be a quadratic function. Conversely, if it's concave down, the a value would be negative, and the graph of the function, of the quadratic function, would be facing downward, like so. As we move on, we'll see other attributes. So this point right here, -1, -4, is a minimum point since the graph is facing upward, since it's concave up. Since it's our lowest point, we call this a vertex. So it's both a minimum and it is our vertex. And a vertex is either a minimum or a maximum. So minimum or maximum. This quadratic function also has an axis of symmetry, which is a line that cuts it in half to make two equal pieces, and the line will always cut through the vertex. This x value of the vertex is how we get our equation. Vertical lines are in the equation x equals, and we take the x value of where they cross the x-axis. We also talked about roots. Roots are where the quadratic function crosses or touches the x-axis. So these points here would represent our roots. And so our coordinates of our roots are always a number comma 0. So since they lie on the x-axis, they're x-intercepts as well. So roots and x-intercepts are synonymous. Go ahead and take a moment, make sure that you have all the information added onto the graph and labeled. We'll go ahead and we'll move on in about 30 seconds. Okay, so now it's time to take this information and put our vocabulary into a definition. So our axis symmetry. So it was the line x equals -1, and this is a vertical line that cuts the parabola in 2 equal parts. Remember, the vertex can either be a maximum or a minimum. So our definition, it's the point that is the highest or the lowest point of a parabola. So the highest or the lowest point of the parabola. We use the acronym ROCKS to represent roots, it's not a no, it's a 0, x-intercepts, and solutions. Many times these terms are used interchangeably. And as we use them, we want you to know that we're still looking for these points where the function crosses the x-axis. Zeros and solutions will become important later as we factor and we solve quadratic equations. So in this case, our roots were -3, 0, and 1, 0. And the last bit of information I give you is that a quadratic function can either cross the x-axis twice, like the parent function, it could touch it just once, or maybe even you have a u that doesn't even touch it at all. So the roots are either 0 row roots, 1 row root. Later we'll talk about that this is a double root in the polynomial unit. Or it could have 2 row roots like the graph that we're seeing here. This concludes our notes. When you're finished taking your notes, you'll have a short packet on quadratic attributes. You'll be labeling and showing us the minimum, whether a graph has a minimum or maximum, finding the coordinates of the vertex, stating the concavity, finding the roots, and the axis of symmetry. We'll also spiral back to including domain and range, and looking at some application or real-world problems. Thank you for your time.